Hello, my name is Jenna Morrissey, and I am joined with Jennifer Buchner and Victoria Rodriguez presenting our ES 451 Capstone Final Project of Enterococcus resuspension from wading in the East River.
Hi, I'm Jen.
Hi, I'm Victoria. The main objective of our study was to examine the impact of sediment resuspension on Enterococcus and turbidity in the East River. Along the East River, there are combined sewage outflows, which contain both treated and untreated waste that gets released into the river when it rains. Enterococcus is a fecal indicator bacterium that can be used as an indicator to differentiate between pristine water and waters contaminated with fecal matter. Sediment resuspension from wading is an efficient method to determine in what conditions Enterococcus will remain in the sediment. A factor that plays into resuspension is the type of sediment that is present at the site. Different types of sediment can hold Enterococcus for longer periods of time. The procedure that we followed helped to determine the potential for shoreline sediment resuspension in shallow waters. Sediment was taken before and after to determine if Enterococcus was really being resuspended. The two sampling locations were Site IT and Site MAR, which are both located on the East River.
Site IT is located off campus, while Site MAR is on campus.
Site IT is in close proximity to a CSO, so it is expected to see a high turbidity and Enterococcus readings at this site.
At each testing site, we walked into the water with our waders until we reached the depth of 30 centimeters. Sediment was resuspended by us kicking it for 30 seconds, and then we took water samples after 1, 2, 3, 4, and 5 minutes into 100 milliliter plastic bottles. Sediment samples were then taken at a depth of 30 centimeters in glass jars. Here is a video of us kicking up the sediment. Back in the lab, turbidity was measured using a turbidity sensor, and Enterococcus was measured by following the IDEX procedures. Samples were placed in trays and then placed into an incubator at 40 degrees Celsius for 24 hours. Results were then read under a UV light. Our first sampling day was November 11th, and that was our wet sample. It rained 0.205 inches. In Figure 2 at Site turbidity increased from 73.8 to 92.9 NTU, and Enterococcus increased from 30 to 52 MPN after disturbance. In Figure 3 at Site MAR, turbidity increased from 9.4 to 23.8 NTU, and Enterococcus stayed the same at 10 MPN after the initial disturbance, but eventually settled down at minute 2 to 9 MPN. November 19th was our dry sampling day, and it rained 0 inches. In Figure 4 at Site IT, after disturbance, there was a decrease in turbidity from 77 to 75.5 NTU. Enterococcus also decreased from 20 to 9 MPN, but spiked at minute 2 with a reading of 31 MPN. In Figure 5, at Site MAR, turbidity increased from 7.3 to 10.1 NTU and then settled. Enterococcus decreased after the initial disturbance, but then spiked at minute 3 with a reading of 148 MPN. In Figure 6 and 7, we conducted a closed sediment trial to see how different each sediment type was at the sites. Site IT had a higher Enterococcus reading than MAR due to its location close to a CSO. Site IT also had slightly silty, muddy sediment, which holds more organic carbon content than sand, which MAR has. There is a direct relationship between organic carbon content and Enterococcus, which explains the difference in these two readings.
After disturbing the sediment, Enterococcus and turbidity levels increase, which indicated that there was bacteria resuspended, which can be seen in figures 2 through 5. IT had higher Enterococcus and turbidity levels than MAR, which could be due to IT being in close proximity to a CSO. The sediment held a greater amount of bacteria at site IT than site MAR. This could be due to the different type of sediment at each location. The sediment at site IT was muddier and silt-like, where sediment at site MAR was coarse sand. Muddy sand holds higher levels of Enterococcus, and coarse sand can hold less Enterococcus. Coarse-grained sand holds a small amount of organic carbon, and fine-grained mud has a high organic carbon content. There is a positive correlation between FIB and organic carbon. The resuspension of the sediment causes a mixes of the water column. That could be why nearshore samples have higher FIB concentrations than a sample if it was taken from offshore samples. Under wet conditions, the two sites are different in Enterococcus values. Under dry conditions, there is no difference in Enterococcus values between sites. The differences could be attributed to the CSO discharging raw sewage in the water when it rains. Sediment disturbance of any kind can potentially lead to resuspension of Enterococcus or any other toxins present in the sediment. Based on what is being resuspended, the water quality of coastal water may vary.
And this concludes our final presentation of our Capstone project. We hope you enjoyed and learned about Enterococcus in the waters, and don't swim in the East River after it rains.
Thank you for listening.